one of the things that we started with yesterday was we're talking about ratios around the unit circle, okay? And again, we call it the unit circle because why? Why is it referred to as unit circle? Okay, that's a good point, but that's not why. Why is it the unit circle? Because the radius is 1. All right? So the distance from here to any edge of that circle or any part of that circle has a unit of 1. All right. Now, what we are doing is we're setting this up so that we can find the coordinates around the circle, all right, just based on the angles that are made to get those coordinates. That's what we're working towards. Okay? Now, if I look at just this basic triangle right here, if this is my angle theta, and this is xy, that means the distance from here to here is y. Do we agree? Distance from here to here is x, because that's x and y. What is the sine ratio of theta here? What is sine theta equal to? Y over 1, right? Opposite over hypotenuse. What is the cos of theta equal to? X over 1. So what that means then is that I can now replace x and y here and here with cos theta and sine theta. That's what that means. I can now replace x with cos theta and y with sine theta. And that's what we were working towards yesterday. Fair enough? Okay? Now, in this quadrant, because my x is a negative here, my ratio is now negative cos theta sine theta. Down here would be negative cos, negative sine. Over here would be positive cos, negative sine. And this cast right here means that cos is positive down here, because that's your x value, right? Everything is positive here. Sine is positive here. And tan is positive here, because tan is your y over your x. So if I take sine over cos, and they're both negative, what's two negatives divided by each other? It's a positive value, so tan therefore is positive. Yes, Sam?
What do you mean the radius is 1? Like 1 centimeter, 1 meter?
1 unit.
What's the unit?
Doesn't matter.
So
Right.
it can't be like 4 radius?
Not for the unit circle. The unit circle means that the radius is 1. So that distance from here to here is this. Therefore, this coordinate is 1 and 0. Now, I didn't do this yesterday. You got your calculator right now. All right? On your calculator. Now, I'm going to explain a couple other things this morning. Let's see if we can do a better job of this. On your calculator right now, punch in cos 0. Cos is 0 degrees. What is it?
1.
What's the sine of 0 degrees?
0. 0.
Okay. Is that what I got right here? 1 and 0. Put the cos of 90 in. First of all, what do you think that coordinate is up here? What do you think this coordinate is right here?
1 and
What is it? 0 and 1? All right. Punch in cos 90.
0.
What's the sine of 90? 1. Okay. Let's go over here now. What's this coordinate? Negative 1 and 0. What's the cos of 180? Sine of 180? So what I am doing is I'm showing you ways in which you can solve for very specific angled values, okay, very specific angled values without having to use your calculator. You're going to know how to find the sine of 30 and the sine of 330 without having to use your calculator because they're all the same ratios. And that's all based on this being a representative.
I'm not giving you the same answer.
Go to mode. Is it mode in radians or degrees? Degrees. All right, so yesterday. I'm just gonna go back here, on page, yesterday. And I'm gonna do the very basic one for you, and I'm gonna do a better job of explaining it. Let's take the coordinate 3, 4. And I'm going to find out what the ratio is for the coordinate 3, 4. Meaning, I want to find out what sine, cos, and tan are if I have a coordinate 3, 4. So where does 3, 4 exist? 1, 2, 3. So 3 and 4 right there. We agree that's where that coordinate is? Yep. Okay. So we draw our terminal arm through that coordinate, and we create a right triangle. All right. From here to here, what is the measurement? 3. From here to here, what is the measurement? 4. Okay, so far? What's the radius of this triangle? For me? We're not talking about a unit circle, we're just talking about triangle. What is it, Jake? 5. 3, 4, 5. We often call a right triangle a 3, 4, 5 triangle because that's the lowest whole number that you use Pythagoras' theorem. Okay? So it's a 3, 4, 5 triangle. So now what I want you to do is I want you to tell me what the sine ratio is of theta. 4 over 5. What's the cos value of theta? And the tan value of theta. Okay. Now, here's the thing. When we did this in grade 10, your next step would be to find what? Pardon me? Nope. We've already got that, right? What would I be looking for? The angle. Okay. So let's work with this now. This is new today, not done yesterday, but going to go into what we needed to know for today. So the first thing I want you to do then is I want you to calculate what theta is. All right? What is theta? Three decimal places, please. Awesome. 53.130. That's my reference angle. That is my angle theta. Are we all okay with that so far? Right? Because all the trig does is compare side lengths, but they all give you the same angle, right? So they're all the same as this. Second sine 4 over 5. Okay. Everybody's following so far? Now, here's the thing. There's another angle equivalent to this that will give you the same sine ratio. Another angle that is equivalent to that will give you the same sine ratio. So here's what I'm asking you. This is going back to yesterday. Sine is positive in the first quadrant. What is the other quadrant that sine is positive in? Okay, is the sine the y value or the x value?
X.
Sine y or x? It's y. So what two quadrants are sine positive in? 1 and 2. So if I know this angle right here, right, I can then find that angle right there, correct? And they should have the exact same sine value. So how do I get what this angle is here? What's this angle right here? What do we call that angle? The R word? Reference angle. Exactly. How do I get this? I take 180 degrees minus my reference angle, right? So let's do that. Take 180, subtract that. And what do you get? 126.7. What, sorry? 870. Thank you. Now, if I do the sine of 126.870 right now, I should get 0.8.
You're at 0.778.
Okay, why did you not get it 0.8?
Maybe it's because there was one estimate.
Right, because you rounded off that initial one. Right? Okay, so now that was the sine. This 126.870 has the same sine ratio as that. Now tell me, where is cos positive? Quadrant 1 and quadrant 4. So now, let's find out what that value is. How do I get that value?
Subtract your R from 360.
Awesome. So let's take 360, subtract my R.
Yeah, it's like 0.870.
Okay? Take the cos of that value right now, and it should give you what? 0.6. Punch it in. 0.6. There are always going to be two angles between 0 and 360 degrees that provide you with the exact same ratio. There's why today. All right, now we did that yesterday, but I don't think it really sunk in. Yesterday was a lot of material, so we're going to work back through this again today. Okay, so let's do that right now then. So we did that yesterday. We used the coordinate 12 and negative 9, found all my three ratios, right? Now it's this guy again. Okay, so let's review this guy one more time. And let's find out why and what the whole point of it is. Alright, so what I have done is I've gone in 30-degree intervals all the way around this circle. And I found out what is my ratio of side lengths. Okay? Now remember, each of these are one length in unit. They're all one length in unit. So when I did this, where did these values come from? Where did those values come from? They all come from one triangle, a 30, 60, 90 triangle. What is the sine of 30 degrees? What is it?
1/2.
Okay, we don't use decimals unless given to us, right? So 1/2. We agree? The side opposite over the hypotenuse for 30 degrees is 1/2, it's 1/2. Yes? Okay. What does that make this side length right here? Square root 3. So if I set up this triangle all the way around that circle in 30-degree intervals, my ratio for the sine of 30 is always going to be 1/2. The cos of 30 is going to be what? Root 3/2. The tan I'm not too concerned about because we don't put it on the circle, but we can figure out what it is. In this case, it's 1/√3. Right? The sine of 60 is what? So look at 60 degrees right now. What's the side opposite it? Root 3 over the hypotenuse, which is? Cos of 60? Side adjacent? Hypotenuse? 1/2. Right? And then tan of 60? Root 3/1. What do you notice about the two values for 30 and 60? The ratios are still the same, correct? All we've done is switch them based on opposites and adjacents. Okay, so far? All right, so now, I look,
Our signs are different. One had a √3/2, one had a 1/2. Let's go to that. The sine 30 is 1/2 and sine 60 is 3/2.
√3/2.
Yeah.
Look at 60 degrees right here. Where's the side opposite it?
Oh, √3.
And where's the hypotenuse?
2.
So therefore, the sine of 60 is √3/2. Whereas the sine of 30, where's the side opposite? Over. Okay. All right. So far, so good. So now, all we do is we go around the circle. And we know that in the circle, x is cos theta, y is sine theta. So if that's the case, what's the sine of 30 degrees? 1/2. Cos of 30 degrees? 3/2. And then all we do with the 60 is do what? Switch them. Okay? That's all we do. All I need for you is to finish this first quadrant. Because then all the values are the same all the way around. They don't change. What is the only one thing that does change? Depending on whether x is positive or negative, the value changes. Okay, so far? Now I need to add to this. So take out your circle from yesterday. I'm going to add this into it. We had a second triangle. Our second triangle. Now I'm going to do it slightly different. Oops. Our second triangle is a 45 degree triangle. Okay? Now don't draw the triangle up. Don't draw the triangle up. Okay, there is rhyme or reason to this, but I don't need you to know the rhyme or reason to this. Here's what I'm going to show you immediately. This is what we need to do. We know that if this side is √2, what does that mean that side is? Why? Same angles, same sides across have to be the same value. So here's what I'm going to do. I don't want to explain it to you because I don't think it's going to help you understand it. All right? But what you have to do is you have to put x's in, you have to put a 1 in, and you have to square them. It's a long process. You don't need to know the process. What I need you to know is this. What is the value of sine 45?
0.7.
Excuse me?
0.707. Oh, and a fraction.
Thank you, Jake. What did I just tell you 30 seconds ago, Lexi? We don't use decimals. You use a triangle that tells you the ratio. So what is it? What's the side opposite 45? 2/2. What's the cos of 45? It's exactly the same ratio. It's exactly the same ratio. Which it has to be, because the angles are the same. So then the lengths of the sides have to also be the same across from them, right? And then finally, what is the tan ratio? Which is 1. You're right, √2/2. √2/2. Okay, it's 1. So now I'm going to add that into my unit circle. Because all the 45 now. So let's have a look. 45 degrees. What's my cos ratio? 2/2. What's my sine ratio? 2/2.
So, like, when you use √2, can we use 1 instead? Like, just kind of like 1 and 1 and then √2?
1/√2.
Instead of saying √2/√2, just put a 1. You can do that, right?
I don't know, I just saw.
They're not over. It's not √2/√2. It's √2/2.
Oh, right.
Those are not the same thing. Lexi, I'll explain what they're doing there in a second. Okay, so now I have 135 degrees over here. What's my ratio over here? Do the numerical ratios change? No, what changes? A negative. So what is this? That's right. Okay, down here. 225 degrees. What is it down here? Both are negative, thank you. And then over here, 315 degrees. Positive root 2 over 2, Juno, and that girl. Negative root 2 over 2. Good. All right. Now, I had difficulty with this when I first started. When I first did this, I found it difficult. So if you're struggling with it, that's probably to be expected. You have to be able to draw this all out, not this year, but you do need to in grade 12. So we have to try and get a good grasp on it right now. Yes, Sam?
So we wouldn't need a 90 because 45 and 45 and 90.
Which we already know that 90 degrees is that value. Right? So this is the thing. I go 30, 60, 90, 120, 150, 180, or I go 45, 90, 135, 180. Right? So they're all in intervals. These are the specific angles. The reason that we need to know them. This is the hard part. What in the world do we need to know this for? Because in grade 12, these guys are about to find out in a couple units here. In grade 12, what happens is we have to do all of this stuff without a calculator. So now, the next question is, can you tell me what the sine of 15 degrees is? The answer is no. Nice try, nice. And again, you're using decimals. Great. Okay. Can you tell me what the sine of 15 is? You can't. You can't do it. All right? Not yet, not now. Yeah, you can off your calculator, but we want to do it without the calculator. So there's laws that we have to learn. So if we can hammer this out in grade 11, then when we do this in grade 12, it becomes second nature to us, and it makes the unit go faster. So it's going to take some time. All right? So that's where we're at today, so far. Okay, so yesterday we left off, we did working example 2. I left off on working example 4B. So I want to talk about it. Now, I want you to follow along in your book with that working example. So flip over to page 72, please. Now I suggest you keep this beside you. In fact, I'm going to give you a nice copy of it tomorrow. But right now you keep yours beside you. Now, here's what the question says. Looking at, everybody's on page 72. It says the cos of theta is equal to negative 1/2. Negative 1 over root 2. Which is actually what? If I rationalize that, what is that value actually? It's this. Root 2 over 2. Okay? Times the top and the bottom. I'm trying not to go into radicals yet, because we are going to do it. But I'll just show it to you right now. Okay? 1 over root 2. If I rationalize this denominator, means I want to get rid of a square root on the bottom. I times the top and the bottom by that. Okay? So this is grade 10 work right now. Did this in applied as well. That gives me root 2 over, what's root 2 times root 2? 2. Square root 4, which is 2. So that's the same value. 1 over root 2 is the same value. Everybody follow that? Again, I'm not doing radical work because that's not what I'm asking you to do. So now we go back to this. So what I'm asking you, the question is saying, on page 72, where on that circle is theta equal to negative root 2 over 2? So looking at that circle right now, you tell me the angle, this is what the question's asking, between 0 and 360. You tell me what is that angle of theta when the cos of that ratio is negative root 2 over 2. What's the first one? You said quadrant 2, which is angle what? 135. And Sam, the next one?
225.
There's your answer to that question. Both the angles. So let's read this. And let's follow it in. Determine which quadrants the solutions will be in by looking at the positive or negative sign of the given ratio. So that's the first thing I did, right? I said, okay, where is cos negative? So which two quadrants is cos negative in? Where's your x value? 2 and 3, so write that in. Cos theta is negative in quadrants 2 and 3. Cos theta is positive in which two quadrants? 1 and 4. So let's put that in our book.
So your cos is always your x?
So the solutions are in quadrants what? 2 and 3. So we solve for our reference angle. Now this is the one thing that I didn't do today that I did yesterday. So I'm going to go back and do yesterday's question in a minute again. But I always like to find the reference angle. Now in this case, because these values are directly on the unit circle, I'm going to leave it. But the reference angle is this. What is the positive ratio? So what's the positive ratio for cos theta equaling root 2 over 2 in the first quadrant? What's the angle? Where does cos theta equal root 2 over 2 in the first quadrant?
45 degrees.
45 degrees, so that's your reference angle. So write that down as your reference angle. Then it suggests we sketch it, which we've already done. Now, the first angle is in which quadrant? When cos is negative. Quadrant 2. So write that down. And how do we find it? He even spells it out for you there. You take 180 and you subtract your reference angle. So what's 180 subtract your reference angle? Right, so we already had that. So they're doing excess work for you because they're showing you angles that aren't on there. So I'm going to do an example with you in a second on that. The second angle is in which quadrant? 3. Okay, so I've got 180 plus that. So what does that equal? 225. The solutions to the equation cos theta equals negative root 2 over 2, 0 degrees less than 360, are in angles 135 and 225. Very good. All right. So if you have the angles actually on the unit circle, you don't need to go through the whole process they just did. But I'm going to show you one in which we did yesterday, in which you have to go through the whole process, okay? So first of all, are there any questions about what just happened here? Because I'm about to quiz you. Yeah, go ahead.
Why would you change the negative 1 over root 2 into the root 2 over 2? Why would you do that? Like, I know how
Okay.
you did it, I just don't know why.
Because we are taught in grade 11 to rationalize denominators, okay? In grade 12 text, this is how they write them, okay? So
the negative 1 over root 2 just doesn't exist on there, so you have
It's right
to.
here. That's it right there.
Okay.
Because of this. Okay, so if I just had to put that there, right? That's where it exists. Okay? Now I know it confused you. This textbook is different than the grade 12 textbook. Alright? but we want to rationalize that denominator just for this root 2 over 2 value, because it's the same. We want to keep it consistent, okay? All right, so that's a good question. So now, let's go and let's do one more example. I'm going to do a 1 unit circle example with you, and then I'm going to do an example in which it's not on the unit circle and how we go through the process. So look at your unit circle right now, please. And all I want you to do is, first of all, tell me the quadrant, okay? Looking at your unit circle. Where is sine theta equal to negative root 3 over 2? Which two quadrants?
Oh, 40.
Which two quadrants? 3 and 4. Okay? So we know that this occurs in quadrant 3, and this occurs in quadrant 4. And again, on your exam, you would look at just your unit circle, just to solve this question. Okay? So now, what's the angle in quadrant 3? 240. What's the reference angle, just for the heck of it? What's the reference angle? Yeah, very good. Okay, in quadrant 4, what is it, Lexi? 300. Okay? That's how simple it is. With the unit circle in front of you, that's how simple it is. Okay? So now, any questions about that? So all you're doing is just identifying off of that circle right now, and you are allowed to have that beside you. Okay, for right now, you're allowed to have it beside you. Okay? So now, here's, to answer that question, or the question that just came in, here's why we have to work with the reference angles now. So here's what I want to do. I want to find out, this you may want to write down, this isn't in your book. Okay, so just put it in the margin on your book or somewhere, top of your book, somewhere where you can kind of watch the process of this. Okay, so I want the cosine theta to be negative 0.525. Oh, here.
Wrong book.
Yeah. Cos theta is equal to negative 0.525. First thing I want you to do, identify the two quadrants this angle is in. Where's cos negative? 2 and 3. Okay, so we know our solution has to be in quadrant 2, and our solution has to be in quadrant 3. Okay, so we're in around 72. Okay, so now what I want you to do is I want to find out what the reference angle is. So I'm going to draw myself just a grid, and I want to find out what is my reference angle. So now you're going to use your calculator for this. You can use your calculator for this, and I want you to do the positive ratio. Positive ratio, so do second function cos of 0.525. 58.32. Thank you. 58.332. There's my reference angle. Is that a part of my solution? Meaning, is that one of the ratioed angles? No. Why? What did I just find? My reference angle, but it was a positive. Agreed? But the ratio that we're looking for is the two negatives. So we now need to find out what is the angle in quadrant 2. So what's this angle? All right? Take that away from 180. And what do you get?
121.668.
Awesome. What is the other quadrant that it's negative, Jeffrey?
3.
3. So now, Jeffrey, I want that angle down there, which is that. How do I get it?
Well, 225.
Not 225. It's not on your circle, Jeffrey.
Okay.
This is my reference angle here, right?
180 plus this.
Very good.
Why are we doing 180 now?
Well, Sam, what's the distance from here to here? What's that angle? 180 degrees. And now I'm adding on this amount. What is that amount? 58.332. Right? Okay, so what does that work out to?
238.332.
Thanks, Jeffrey. 238.332. There's my solution. There's my solution. Okay? That's all of 2.2. The thing is, this is a massively important section to us, so we have to spend time on it. Okay? Because we need it when we do grade 12. All right? Any questions about this so far? We haven't done any work on it. So let's kind of pop back and let's do a quick overhaul. All right, so the first thing we did, identified that cos was x, the ratio of cos is x, and sine is y. And that the unit circle meant that the distance from here to here is 1. Okay, finding ratios, we understand that there is more than one ratio that has the same value on a unit circle, or on a circle. Sample questions? We want to keep this beside us. If you can fill in this first quadrant, all of these quadrants are the same, with one exception, the negative signs. So as long as you can do a triangle sine 30, triangle sine 60, and a 45-45 triangle, you can get all the values you need. And that's right at the end.
In grade 11, we get to have the triangle before us. Or the circle.
Circle, you're gonna hold the circle. You do get it. Grade 12, they have you draw it. They'll give you an insert in your exam booklet and you draw it. So you do need to know it. In grade 11 right now, I just need you to be able to work with it.
So
Okay.
our, I don't know if it's our terminal arm, the one that's on the diagonal for all of our.
That's the terminal arm.
It's always positive, right?
For which?
For any of the angles in the circle.
Yeah. As long as we move in a counterclockwise direction, yes. Okay? If we go in the other direction, all the angles become negatives.
Do we ever go in the other direction?
Not till grade 12. Okay? All right. You have the remainder of today. Work on 2.2, and we'll check that over tomorrow. Okay? So most of you should be, all of you should be started on 2.2. All right? Okay, 12. Let's answer some questions here. No, I'm okay.